This video is going to be on factoring quartics. Remember, a quartic is a polynomial with a degree of 4. So the highest exponent in all these problems is going to be a degree of 4. And so we're going to look at two types of situations. The first is going to be difference of squares. And then remember, that's a perfect square, something like a squared minus b squared. So a perfect square minus perfect square. And then we're going to look at quadratic-like problems. And quadratics are, remember, ax squared plus bx plus c. So we're going to look at two types of quartic problems. Let's look at the difference of squares problem first. These are fun. I like these. So example 1 for difference of squares. Let's go with x to the 4th minus 16. Alright, so 16 is a perfect square, and x to the 4th is also a perfect square. The reason x to the 4th is a perfect square is because it came from x squared times x squared, and so since it's the same thing multiplied by itself, by definition, it's a perfect square. And so to do difference of squares, remember, we square root in our mind each term, and then we just use the formula a minus b, a plus b. And so the square root of x to the 4th is x squared, and the square root of 16 is 4. So we use the formula x squared minus 4 and x squared plus 4. The fun part about these problems is that sometimes you end up being able to factor some more. So you always have to ask yourself, can I continue to factor? And in this case you can, because you have another difference of squares problem with the x squared minus 4. You cannot factor x squared plus 4. So x squared minus 4 factors to x plus 2 and x minus 2, and the x squared plus 4 stays the same. Alright, let's try another one, maybe a fun one. We'll see if we can get something good. Let's go with something like, who knows, x to the 4th, and then let's go with minus, I don't know, 81. How's that? And so it's difference of squares. X to the 4th is a perfect square. 81 is a perfect square. And so it would factor to x squared minus 9 and x squared plus 9. And then you have to ask yourself, which one of these can I factor, if any of them? And I can factor the one that's a difference, a minus sign. So this would be x plus 3 and x minus 3, with the x squared plus 9 staying the same. And that's how you would factor a difference of squares problem. Let's go with quadratic-like problems. Quadratic-like. So a problem that would be like a quadratic would be something like x to the 4th plus 3x squared plus 2. The reason it's like a quadratic is because of the exponents. If you look at the exponents, 4, 2, and then nothing, they go down by half and then it disappears. And so it would be just like factoring, just like if I were to ask you to factor x squared plus 3x plus 2. By this point in your math career, you should be able to factor x squared plus 3x plus 2. The way we do it is we say what multiplies to 2 and adds to 3. And so the two numbers that multiply to 2 are 1 and 2. And those two numbers add to 3. And so we write x plus 2 and we write x plus 1. There's nothing different in regards to these problems. There's nothing different in regards to these problems. All you do is you're going to use x squared instead of x. So it would be x squared plus 2 and x squared plus 1. And then you just ask yourself, can I keep factoring? And the answer is no, because they're both x squared plus a number, not minus a perfect square. Alright, so let's try one more. let's go with x squared minus 5, or not x squared, we want x to the fourth, right? X to the fourth minus 5x squared, and then we'll go with minus 36. And so we're basically just going to say what multiplies to negative 36 and adds to negative 5. Two numbers that multiply to negative 36 and add to negative 5. And I guess those numbers would be negative 9, so x squared minus 9, and x squared plus 4. I like these problems because you have to ask, can I keep factoring? We can factor the x squared minus 9 to x minus 3 and x plus 3, but we cannot factor x squared plus 4 because there is no minus sign in between them. It's a plus sign, so we're going to leave it as x squared plus 4. And that's how you would factor something that's quadratic-like. I will do one where we might need to use the triangle method, because we had to use the triangle method with quadratic polynomials when we factored those. So, for example, let's go with 2x to the fourth, and then we'll go with plus 9x squared plus 4. Okay. Triangle method says to multiply the first and the last together. That would get you 8x to the fourth. And so you'd say what multiplies to 8 and adds to 9? The two numbers that multiply to 8 and add to 9 are 8 and 1. And so it doesn't matter what order you put them in, so I'll put them in as 1, but you've got to put an x squared with it, plus 8x squared, and you keep the first one the same, 2x to the fourth, and you keep the last one the same, plus 4. And now that you have 4 terms, you want to factor by grouping. So group those two and group these two. And so the GCF for the first pair is just x squared. Take off the x squared from each, and that would leave you with 2x squared plus 1. And then the next one, the GCF, between 8 and 4 is just going to be 4, so plus 4. And it leaves you, as we divide into each one, 8 divided by 4 is 2, and then 2x squared. 4 divided by 4 is 1. Once again, notice parentheses are the same, so that's good. And we will finish the problem by saying 2x squared plus 1 times x squared plus 4. It may seem like you can factor x squared plus 4, but you can't because it's not minus. And so this is our final answer. And so factoring quartics is just very similar to factoring quadratics, and that's how we're going to do it. So have a great day. Talk to you soon.